So number 24, I think, is one of the most challenging types of problems we have on this exam cycle, where it wants us to figure out the silver ion concentration for a reaction, and they give us information about the thermodynamics. And so they tell us the concentration of chloride ions, and see how we're not at 1 molar, we're way below 1 molar. That's not standard conditions. And then they give us the delta G for where we are at, and then the standard delta G for this reaction. And we can combine non-standard conditions together into this equation that I've written here. Delta G equals delta G standard plus RT ln of Q, where Q is our reaction quotient. And so what we're going to do is solve for Q using the equation, and then we can use the value of Q to solve for silver ion concentration, knowing that the concentration of chloride is that 1 times 10 to the negative 10 molar. Okay, so let's set this up. I'm going to add something to our table, which is just the temperature from the problem above, which they tell us is 298 Kelvin. Okay, so we'll have our non-standard delta G of negative 58.496 kilojoules is equal to the standard delta G, which is positive 55.6 kilojoules, plus R, so I need to put the R in kilojoules, so it's going to be 0.008314 kilojoules per mole Kelvin. Times temperature, which is 298 Kelvin, times, ln of Q. I'm sorry, that's bad. So it's that times the ln of Q. Okay, so I'm going to subtract over the standard delta G. And so once we have subtracted over the standard delta G, we have this set up, and we're going to divide by RT to get the ln of Q. And once we're here now, we can say Q equals e to the power of negative 46, which is equal to 1 times 10 to the minus 20. Okay, so now we can use this Q in the setup up above. So we'll have our Q, which is 1 times 10 to the minus 20, is equal to the concentration of silver times the concentration of chloride, which is that's negative 20, not negative 2. 1 times 10 to the negative 10 molar. And when you solve for this, you'll get that the silver ion concentration ends up also being 1 times 10 to the minus 10 molar. Okay, so the answer here is A. So make sure you're comfortable working outside of standard conditions and combining delta G and delta G naught. Okay, last one. Woo! Almost there. So in this one, they want us to figure out which will produce the most basic solution when dissolved in water. Okay, and so do you see how these are all molecules with a deprotonated oxygen? So all of the oxygens have a negative charge, meaning that they've lost a proton, or H+. And so these are all conjugate bases of some weak acids. And we know that relatively the strongest conjugate base will be the conjugate of the weakest acid. Okay, so what I'm going to do is go through and write these as if we're thinking about acids, and then we can pick the weakest acid. So ignore those negative charges. Okay. And so we know that we increase the acid strength when we have more electronegative atoms pulling electrons away from the hydrogens. And so since we're looking for the weakest acid so that it would have a stronger conjugate base, we want to look for the molecule that has kind of the fewest number of electronegative atoms attached. So if we look at molecule A here, on this carbon, we have 3 bromines attached. And bromines is somewhat electronegative. Cl, if we have 3 chlorines, that's pretty electronegative. 3 fluorines, super electronegative. And then down here in D, we only have 1 electronegative atom. And in E, we only have 1 electronegative atom. So we've replaced the fluorines with hydrogens, or the bromines with hydrogens. Okay. And so option E is going to have the least electron withdrawing from the hydrogen. Right, we only get 1 little dipole pulling away toward that side of the molecule. And so this would be the weakest acid of the 5. And so of the 5, it will have the strongest relative conjugate base strength. Okay, so a solution of E would be the most basic. And that's it for practice exam 3A. Keep up the hard work, okay? Keep using videos. Make sure you put pen to paper though and do them for yourself too. And make sure you're comfortable using your Chem 112 calculator and your data sheet, and that you go into this exam well fed, well rested, and confident in your abilities. Okay. Talk to you guys later.